Okay.
Hey everyone, welcome back. So, good morning, good evening, depending on where you're in the world. Welcome to the second session on our RAG and Agents Bootcamp. Today, we will dive deep into building RAG pipeline using LlamaIndex. Please join me in welcoming our speaker, Ravi Theja, who is a developer advocate engineer at LlamaIndex, and he also builds Indic large language models at Navrasa and is also been awarded by Analytics Vidya as one of the top 5 generative AI expert in this field. So, giving you a brief agenda of today's session, we will first look into simple retrieval augmented generation workflow using LlamaIndex. In our previous session, in the introduction section, we have already seen how a RAG workflow actually works. Today, we will actually look into how we can implement using LlamaIndex. Further, we will also implement agentic RAG using LlamaIndex. And if time permits, speaker will also show a demo on LlamaCloud, an advanced method to efficiently extract your data information. So without further ado, let's start with the session. So
Shall I
we'll wait
start?
for 1 minute. We'll
Sure.
just wait for 1 minute. Until then, if you have anything else you wanted to share from your end, you can do that.
I mean, let's wait for 1 minute and then we'll start.
Cool. Okay.
Cool.
So there is a question before we can begin, like how best should I follow along? So do we have any collab notebook that we are supposed to share?
No, I thought this is more of a PPT session than a demo session, so I just kept slides.
Okay, okay, understood. So will do we have any notebook as well in the end
No, I did
that
not.
can be
No.
okay. We can share it later, right? Like whatever is there in the slide, I'll.
Yeah.
Okay, cool. Yeah. So after the end of the session, as I mentioned in the session one as well, we have the content page. We will be uploading the notebook after the session as well. Okay, I guess we can get started now.
Okay, cool. Let me share the screen. This visible?
Yeah, this screen is visible on the screen.
Yeah, cool. Hey everyone, uh, good morning, good evening, and good afternoon, in whatever place you are in. And thanks, Tarunji, for giving me the opportunity to present about Agentic AI with the audience. Myself, Ravi Theja, I'm a developer advocate or an engineer at LlamaIndex. So let's get started with it. I'll be giving a flow of what RAG system is, and then how we are moving towards Agentic RAG, and then give a demo of LlamaCloud or enterprise solution for building effective retrieval and augmented or context augmented generative applications as well. So let's get started with it. LlamaIndex, as you have, Tarun has already mentioned, you guys have already seen what RAG is. So LlamaIndex is a framework, open source framework, started as an open source framework, which helps you build, uh, which helps you build. Okay, I think I'll be taking the questions towards the end. Maybe Tarun, if you want to pitch in between, you can pitch in for the in the comments.
Yeah, sure, sure. We'll be taking in between, like after certain slides.
Yeah, cool. Thanks.
I'll be moderating in the back.
Yeah, sure. So LlamaIndex is an open source framework for building context augmented LLM applications. So data sources are in different format and different ways, right? Like in Slack channels or Notion documents, PDF, audio, video files, different formats, SQLDBs, Pinecone, and various other stuff. And LlamaIndex has a centralized framework to connect LLMs with these different data sources to build RAG applications or agentic applications. In in simple words, like we have three components, high-level components, data ingestion, LlamaHub.ai, there are a lot of connectors which helps you to build, ingest data from these different data sources. And then once you ingest, we provide indexing mechanisms to index the data. And then once indexing is done, we have agents, retrieval, and responses modules to when a user queries or want to do some task, use these indexes and use the retrieval systems and responses to complete a task or generate a response for the given query. So let's look into RAG stack, right? So given a document, we create chunks out of it with different chunk size or chunk overlap and all those parameter, different splitter and all, and create embeddings and metadata for each of these, and then push it to vector database. Okay, this is the data ingestion or parsing stage. And then in the data querying stage, given a query, it retrieves some of these chunks and sends it to LLM and generate a response. So this is a pretty simple RAG stack. Within just 5 lines of code, you can start working on your RAG application. But then these prototypes are very limited. You can call it as a naive RAG stack, and so this helps you to answer some of the queries like what are the main risk factors of Tesla, or what is the revenue of Tesla or Uber or Lyft in 2021, 2022, or something, when a single document is indexed or two or three documents are indexed. Or maybe something like what did the author do during YC time when a paragraph says indexed. But then there are quite different challenges with RAG, right? There are different pain points, right? Something like the questions can be different. Summarization questions, like given an index document, you can maybe ask and give me a summary of this document, and then comparison questions, compare the versus contributions of candidate A and candidate B, and then structured analytics, like where you combine both your RAG retrieval system with SQL DB as well. Something like tell me about the risk factors of the highest performing SlideShare company in the US. Okay, and then multi-part questions, like you have different questions in your query, and then you want to break down those questions and then get answers and consolidate at the end, right? So these some pain points in dealing with naive RAG and building. How can you build dynamically with all these things? Like each question requires a different pipeline implementation, right? Summarization is different and comparison is different, and then structured analytics is different, and then general multi-part questions is different. How is it different? Summarization, it requires a whole the RAG system or your system to look at whole documents rather than just retrieving some of the chunks. And for the comparison, probably you want to break down your comparative question into two or three different questions, get answer for the individual questions, and then combine them. And structured analytics question, it requires text to SQL setup instead of RAG, or maybe a combination of both. And general multi-part questions requires decomposition and then planning and reasoning and tool use and all those stuff. But then in a real world situation, how can you handle these different type of questions dynamically? That's where agents will help you. So simple RAG system, what can it do? It can do a single shot query, or and it can't understand, don't have query understanding or planning, or it doesn't have any tool use or error correction mechanism. Like if I get an answer first step, maybe I can reiterate over it and then try to get a better answer at the second or third iteration, right? And it's no memory, so stateless. And these are some problems with the usual naive RAG stack. And then moving towards agent, as said, the queries can be different, right? It can be related to summarization, it can be related to text to SQL or different documents. or various other different kind of queries we have seen. So can we implement an agent to for different queries dynamically? And then there are different tools as well as one of the tool can be RAG as well. So agentic definition can be using LLMs to automated reasoning for tool selection as well, right? So given as seen, we have different types of queries. So probably we can use these LLMs for automatic tool selection or automatic reasoning, right? So and RAG is one of these tools, so that agent can decide to use one of these RAG tools as well. And then so this is where we are going from simple notebook to advanced agents. So we have routing, one-shot query planning, tool use, React, and then dynamic planning and execution. So as I said, we have different queries, right? One is summarization query, or maybe a query that is retrieving top K chunks. So given a query, you have a router and you have two different indices. A vector query engine or summary query engine, and then given a query, this router will route the query based on its intent to a vector query engine or summary query engine. So here the query is what did the author do during his time in art school, right? This is not a summarization query; it's a query that can be answered with respect to specific context. So just route this query to vector query engine or vector index and then get an answer. Let's say the query is something like what is the summary of the document. It should route to summary index or summary query engine where it retrieves all the chunks or nodes uh, and generate an answer accordingly. Right, this is the simplest form of agentic reasoning, where you use an LLM to understand the intent of the user query and then route it to different uh, indices. And then if next one is if you want to do query planning, like given a query, let's say compare revenue growth of Uber and Lyft in 2021. So you need to create a query planning, right? You need to decompose the given query into two different questions. Describe revenue growth of Lyft in 2021 and describe revenue growth of Uber in 2021. And then you just pass these questions to specific documents indices and then get chunks for each of these documents for these queries, generate answer individually, and then accordingly consolidate at the end. So this is how a query planning is done here. So yeah, this is the example as I discussed. And then so there are different tools as well, right? Use an LLM to call an API. You have a query and then you have a metadata as well. So based on the query, you probably retrieve some metadata from the query and then filter out the nodes present in the vector DB and then retrieve those specific nodes which can be which belong to this specific metadata. And this will help you to get better retrieval nodes. And then even for text queue SQL, you give a query, LLM will create a SQL query and then generate an answer. And then probably if you have a calendar API, Google Calendar API, you query it and then you get some information from it, hit the Calendar API and get an answer. So these can be used as different tools, right? So in normal RAG, you just pass through the query. But if you use the LM to infer all the parameters for the API interface, so these are some things that are possible. A key capability in all these use cases, auto retrieval, text to SQL, calendar, Slack APIs, or any other different APIs possible. So this is cool, but how can an agent tackle sequential multi-part problems, or how can agent maintain state over time? Right? Probably we can add basic memory, or we can make it a loop, right? So that's where data agents or the agents concepts come in into play. into a next stage from what we have discussed. So we have all these different tools, right? It can be Google Calendar API or text to SQL or RAG tool or maybe Slack channel to update some message to your Slack or any other tool, right? So what it happens is given whenever a user sends a query, the agent will reason out based by using LLM based on its reasoning capabilities. It will select one of these tools, okay, and then once it selects one of these tools, it uses the tool, either RAG tool or maybe any other API call, to query the specific tool and then get an answer from it. And if the answer is not, if the final query is not yet answered, it probably can choose some other tool in the second iteration and then get an answer accordingly. So this way you use LLM with the help of its reasoning capabilities to select one of these tools, get an answer, and see if the answer is finally reached for a given query, and then keep iterating over it. So this can be done using two ways. One is React Agent. With any LLM, it is possible. It's a React is a prompt wherein you have thought, action, observation, and iterate this three-step process and get the final answer. Or you can still use any OpenAI LLM, basically function calling agent capabilities. I think here we have function calling agent bucket system right now instead of OpenAI agent. So you can use OpenAI function calling capabilities or Anthropic function calling capabilities or Mistral AI function calling capabilities. And then you have all these tools, different tools, query engine tools, or Llama Hub tools. As I said, Google Calendar API and Slack channel API are different. There are multiple number of tools, large number of tools, 30 plus tools in the Llama Hub, where you can plug into these tool systems and accordingly we have the agentic system. So I said here is the React agent framework. So LLM has reasoning only, for example, chain of thought, and then there is act, with actions and observations, right? And then there is React, right, which combines both of these. You have reasoning capabilities, and it takes actions, it observes, and then again reasons itself, takes actions, observes, keeps on iterating this whole process. So this is one example wherein it has tools related to Houston and then Chicago. So here is a query: tell me about the demographics of Houston and compare that with demographics of Chicago, right? So it first has access tool related to Houston with an input of demographics. It gets an answer, and then Chicago, it gets with an input demographics, it gets an answer. Now it combines both of these and then generates a final answer. So that's how it breaks down into two different queries, function calls, and then get an answer. So you can actually check this guide where Tarun will be sharing later on, and then see how you can build agentic RAG with React pipeline or function calling agent. But then, to summarize it, so we have a better knowledge assistant where there are advanced data and retrieval modules. You have data ingestion, processing, indexing, and then agentic RAG involved in it for based on different queries and get a response, right? And advanced single agent query flows. Like you have, as I said, you can use agentic workflows to for a given query to route route it to different queries. Route it to different indices or query engines or tools and pick something and pick some specific tool or rack pipeline and then generate a response. Uh, you want to take questions, sir?
After this slide, if you want.
Okay, cool. Yeah. I mean, I'm going towards multi-agents probably now.
Okay, so we'll take few questions.
Yeah.
Uh, what's the difference between nodes and chunks in LlamaIndex?
Okay. If you understand chunks is basically splitting the whole document into can say uh, let's say I have a 10,000 token document. Let's say my chunk size is 3,000. So I'll probably have four chunks, right? First 3,000 tokens is one chunk. Second 3,000 tokens is second chunk. Third 3,000 tokens is third chunk, and then rest of the tokens available, which is 1,000, is fourth chunk. Now I want to create embeddings out of it. So these chunks are abstracted as nodes in LlamaIndex, and nodes can have embeddings and metadata information like uh, from which document these chunks are created, when it is created, who has created it, or category of this document, or you can add any kind of metadata, probably what questions this specific chunk can answer, and what question, or probably you can even add what is a summary of specific chunk, so that while retrieval it will be easier and much more useful. So, and then you embed it and push it to vector database. Yeah, this is the whole flow.
Okay, we'll take two more questions.
Yeah.
Is guardrails required for RAG? How does it help?
So when you say guardrails, what does it mean specifically? Based on that, I can help you here.
Okay, so we'll wait for the follow.
Yeah, sure.
We'll take one last. Okay, I guess this should be simple. Uh, it does support.
Yeah, can we use, yeah, yeah. Routing is for multiple choice queries. No, routing is for any query. I mean, you have different queries, right, from the user. Let's say one is summarization query, one is pointed question query, right? So if you and you have for these two queries, you have different query engines or indices, and then based on the query intent, let's say it is a summarized query or pointed query, you need to route the user query to one of these indices. That's where routing will be useful.
Okay, one last question. Like, how does LlamaIndex identify it's a question about RAG or like it's a question of comparison?
So it uses LLM capabilities with some prompt structure to identify whether it's a RAG question or comparison question, and take act accordingly. Like it can combine RAG, React prompt, and other prompts as well.
Okay, I guess we can continue now.
Okay, good. and then uh, and then there are general multi-agent task solvers. Probably basically you have this task, and then you have different agents available. There is this agent which acts as orchestrator, and uh, uh, basically diverts these tasks to one of these agents or multiple agents and gets a response. And that's where we have been building Agentic RAG here, with different set of queries or different uh, different. I think I'll just answer one question here. What happens behind the routing question to a specific tool? I mean, how does it identify which question belongs to which tool? So each tool has a description for it, and then and in the prompt, let's say I have given four tools for the agent, right? So in the prompt, we'll pass description for each of these tools. Like tool one has this description, tool two has description, tool three has this description, tool four has the fourth description. And we'll ask the LLM to classify the given query to so that it can be answered by one of these tools. And accordingly, we'll choose this tool and pass the query to specific API call or RAG tool or whatever it is. That's how the routing functions internally. Cool. Yeah. And then, yeah, continuing it, as we have seen, we have advanced RAG tools, and then RAG and retrieval tools. Given a query, you use these agentic capabilities, and with React prompt or a function calling capabilities, you route it and then get a response for handling complex questions or routing questions as well. But then a single agent cannot solve an infinite set of tasks. You need specialist agents to do much better. And then agents are increasingly interfacing with services that may be other agents as well, right? So that's where multi-agent task solvers come into picture. So why multi-agents? Because each person has his own capabilities, right? Like I have a capability in RAG, agents, LLM fine tuning, right? And then some other person might have uh, in recommendation systems, or probably general fraud detection or something, right? And then in general, to solve a problem in a company, you need to have a coordination between someone who knows LLMs better and someone who knows fraud detection or recommendation systems. And then we both need to collaborate to solve some specific tasks on a higher level task, right? So probably my manager will create multiple tasks for both of us, and first I'll do some task, and then he pass the whatever output I get, I pass it to the other guy, and then whatever he get, probably again pass it to me, and then I'll generate an answer and give it to my manager, or maybe I'll again pass it to the second person. He does some manipulation and give it to manager, or showcase it to the team. So there is a multiple interaction between us, and then sometimes the task can be like he the other person and me were also working on individual tasks, and or both our tasks which complete are completed can give a result as well. So parallelization is important. And then because of specialization, parallelization, and there is cost and latency factor also, which helps you to reduce the cost, and then it should have high latency. And then there are challenges, which is constrained or unconstrained, and how can you define proper service architecture for agents in production. So let's look into it. So agents acts as microservices. Here, each agent will be a microservice, and then which has its own capabilities, right? So this is Llama agents, which we have announced recently, and then so each agent is a agentic microservice, and then distributed architecture, and everything the communications happens with an API interface, a messaging queue, and this will help for you ease of deployment and scalability and resource management as well. So what it has is it has control plane, message queue, and different agent services. What happens in control plane is it has orchestrator, which decides what happens next. So based on the query, it decides which agent to use and all, and then so it sends which agent to use to the message queue, and based on the task available in the message queue, you can basically it sequentially it uses specific agent and compute the task and then give the result. So this is the architecture which I have explained here. Treat every agent as a separate service, and the communication happens message queue, and how orchestration happens via control plane. So implicit coordination and explicit flows. Given an input, user specified agentic workflows and get an output, or else dynamically created agentic workflows like you based on user input, it will automatically create the tasks and get into message queue, and then pick up the task accordingly by the different agents. And then as said, this is local or managed message queue pops up, and then there are different agents as different agentic services, and they keep on uh, communicating with this message queue and pick up the task accordingly. So we have a public roadmap as well, and then look into a lot of examples available. You can check out our repository here. And we are announcing a LlamaCloud waitlist as well. You can sign up here. I'll be just giving a small demo, 5-minute demo. Um, Before that, shall we take some questions, Arun?
Yeah, yeah. So that guardrails was regarding input guardrails.
Yeah, you can specifically keep guardrails in the RAG. I mean, for probably for you don't want to answer your RAG system a specific kind of queries or maybe some moderation and all. You can keep it based on your needs. It depends on specific business use case, right? Based on that, you can design your guardrails accordingly. And then, does LlamaIndex have capability to tell us the costing from LLM in the multi-agent scenario, as there will be multi-agents handling our query and then deciding processing? Uh, I think we are building towards it, uh, or I think we can plug in the costing capabilities because backend it uses LlamaIndex token costing and all, so you can keep track of those costing. How many agents can we include? Is there any limit or any standard as per your experience? Based on the architecture that I have just explained, you can include as many agents you want. Uh, but then, and even if you include large number of agents, it also depends on the task that you are passing it to the your whole multi-agent architecture, right? If it's a very large task, probably it might take more time. Is there any framework to evaluate the performance of agents? I mean, some agents can repeating the same task. I haven't looked into evaluation framework for agents. Probably I can cover it in next session. Um, yeah, I think Ritvik was answering something similar what I was telling. I hope. Yeah,
Okay, so
Llama
we
agents
have
is
yes.
concept using suggestion like Kafka. Yeah, yeah, exactly. Yes. Yeah.
Here we actually left out these two questions like, what if we use well-structured prompt? Will it work as good as agents?
What does well-structured prompt mean?
Okay, so we have to wait for the follow-up question. Probably we can proceed.
Probably I'll just show the demo of LlamaCloud in the meantime. Yeah, so LlamaCloud is an enterprise offering from LlamaIndex to build easier retrieval and then RAG applications as well. So we have two offerings, which is Llama Parse. I could have shown probably because of time limit, I just focused on Agentic, right? So Llama Parse allows you to parse the documents in a specific way that is suitable for building a RAG application. So there are different types of modes. I mean, you can set up. Sorry, I'll just. Is it visible now?
Yes, it is visible.
Yeah, cool. So this has, I mean, you can choose different languages and you can even provide parsing instructions, page separators, and then probably cache can be included or not, and then how to unroll if you want to unroll a column specifically, and then if you want to use GPT-4o for it, and yeah, all these different kind of I mean, it basically suits for if you have documents which has images, tables in it, and then I mean, just directly chunking the tables or images in a normal way will not get you, is not a right way for your RAG application to get an answer, right? So you probably need to parse them in a specific way and then get an answer accordingly. So if there is a table, you need to get it in a very well structured format, in a markdown, probably markdown format, and so that this will get a better, efficient RAG pipeline. So Llama Parse helps you to do that, and we actually have Llama Parse page, so you can just go to this, I mean, document, and then see if experiment with it. And then there is indexing. uh, so whatever RAG application is based on indexing, right? So we provide a managed service to create an index, Probably we'll just create an index here. You can select different kind of sources. Either you can upload the files or S3 bucket, Azure Blob Storage, or Microsoft OneDrive, or Microsoft SharePoint as well. So you can upload it. I'll probably use some of these papers, maybe and then you have index operations like we can manage our own full managed service, or you can use Quadrant or Pinecone as well. And then you can just you can use OpenAI embedding. One second. Uh, Let me get my. So yeah, and then you can you want us to use llama parse, or maybe you want us to use just default open source versions of parsing the documents. And then once all these are ready, you can just deploy index. So backend, it will create the a pipeline, the index accordingly. This will take like 2-3 minutes or so. You can see it is in progress. And then once it is ready, you can interact with the created index by taking the API key, and then you can use it as a retriever, or you can use it as a typical RAG pipeline as well. So both the ways you can do it. And right, I think this is ready. So you can, and then you have three different options like fast, accurate, and advanced.
Okay, so I guess speaker, there might be a loose connection. Yeah, meanwhile, I'll just share my screen and I'll tell you what content we have. Okay, Ravi is back.
Yeah, sorry, I accidentally pressed the enter mark. Yeah, crossbar.
Okay,
Cool.
no worries.
Is it okay? Let me share the screen. Oh, what I'm sharing, like, are you able to see the Llama Cloud earlier?
Yeah, yeah, we were able to see it.
Okay, cool.
You're not sharing the screen now.
This was the screen I was sharing earlier, right?
Yeah, yeah, it was visible. You created the pipeline and then
Oh,
it was loading and then you left.
yeah, cool. Yeah. So, there are three modes, which is default, fastest default one. You can just ask what is multi-hop RAG. So this gives the retrieved files like top three, based 30 nodes, right? So we'll show all these 30 nodes. So what are the nodes that are relevant to the query, right? So here we have all these multi-hop, some, and then we'll show it here. And then accurate is you have re-ranker as well. So we retrieve first 30 nodes and then use the re-ranker. And then you can run it. And then you can see here there is no change in result, but you can see the top three nodes like right after re-ranking. And then there is advanced, wherein you can we have hybrid search capabilities along with re-ranking options, and then test it out. uh, yeah, so for this example there is not much change, but yeah, ideally you can experiment with this different queries and see how you can retrieve the nodes. As said, you can even play around in the playground for the retrieval, or you can even use it via API. You can use it as nodes. You can, retriever, and then you can use it as a query engine, which is RAG pipeline. So that's all I have. If you have any questions, yeah, happy to take it up.
Yeah. So there was the follow-up question on regarding that routing. This means a single query can handle multiple contexts in one go.
What does multiple context mean? Uh, I couldn't understand. A single query, there are multiple RAG pipelines, and you want to route the single query to one of these RAG pipeline, and here the routing will help you.
Okay. Can we use Azure OpenAI for creating embeddings in LlamaIndex Cloud?
Yes, I guess we have that capability. 1 second. So yeah, there is Azure embedding option. Yeah, there is a Azure embedding option.
Okay. So this was the follow-up on the earlier question.
Adding.
What if we use well-structured prompt? Will it work as good as agents? And this was the follow-up I guess for that.
Yeah, you can use different LLMs for different agents, and then all adding all the instructions that we will be adding for separate. Yes, you can do all the instructions separately for different agents.
Okay. And we'll be starting the Ask Me Anything session soon on Discord. Like, if in case we have notebooks on our content page, if you are facing issues on the content page, you can check it out. For this week's session, we have added the notebook on how you can build RAG using LlamaIndex. And the LLM that we have used in the demo is using Hugging Face because everyone has the access token instead of OpenAI. So probably you can play around with the RAG pipeline. So this is it from this session. Ravi, do you have any closing thoughts that you want to share for those who wants to learn RAG and all?
I mean, yeah, keep experimenting and see, join our Discord if you face any problems. And then we'll be soon starting community hours, wherein if you have any specific problems using Llama Index or your use cases, happy to pitch in and then get on a call and help you guys. Probably we'll be starting that from next week. Yeah.
Cool. Yeah. So again, thank you for accepting the invitation and sharing your experience. And we have six more modules and we have six different speakers. Stay updated and we'll be sharing all the updates soon. Yeah. Thank you again. Thank you so much.
Thank you. Thank you.